Good morning, welcome to Vegas Academics Online Tutorial. Thanks for watching our YouTube online. Please, if you have not subscribed to this YouTube channel, please do well to press the subscription button and the notification button so as to see all of our educative videos online. Thanks for watching us. Please also, if you have not shared this video with your friends, families, and relatives that are about to write exams, or they are on their journey on their academics endeavor, please do well to share this video with them and to share this link with them so as to also to be able to be successful in their academic endeavor. Please remember to be your brother's keeper, and God will grant you success in all of your academics endeavor. Now, today we are going to be talking about chemistry paper 2Y private candidate 2019. Now, we're considering the chemistry likely practical questions in GCY 2021, and we're taking samples of previous examples of previous past questions that will enable us to prepare very well for this year exams. And here is 2019 practical, which I know is not really practical, but we call it alternative to practicals. They are practicals. They are information of they give us information of a practical that has been done in the laboratory, and we have to solve the theoretical aspect of the practical. So here is the question number 1 under volumetric analysis in 2019 chemistry paper 3. Now, an acid volume 11.30 cm3 containing 5 grams of LCl per DNQ. Now note some things in the question. Volume of an acid, which is Va, 11.30 cm3, and 5.3 gram of HCl per DNQ. This is mass concentration of acid reacted with volume of a base, 25 cm3 of a base containing Y gram of sodium hydroxide. The equation of the reaction is dash. The equation of the reaction is as follows, which is HCl plus sodium hydroxide plus HCl plus sodium hydroxide plus aqueous sodium chloride plus water. Now, from the information provided, calculate the concentration of the base in mole per DNQ, the value of Y, number 3, mass of sodium chloride from doing titration, and B says state the indicator that can be best used for the titration, and also state the color of the indicator mentioned in 1B at the end point. Now, given that the atomic mass of hydrogen is 1, the atomic mass of sodium is 23, and the atomic mass of chlorine is 35.5. Now, how do you go about this? Now, let's try to solve the first question, which is from the information given, the concentration of base in mole per DNQ. Question of base in mole per DNQ. As you can see from the questions, our acid is Our acid is HCl. Our acid is HCl. Acid is HCl. And our base, which identify that, our base is sodium hydroxide. Our base is sodium hydroxide. Now, we have to calculate the concentration of base in mole per DNQ. The concentration of base in mole per DNQ. And so the only parameters, what are the parameters given to us under for base? What are the parameters given to us concerning base? We said 25 base contains 25 cm3. That the volume of the base, that is the VB, is given as 25 cm3. And look at this. The first cm3 of a base containing 1 gram of sodium hydroxide per DNQ. It means that the mass concentration of which is the mass concentration of B, which is our base. Is given as Y per Y gram per DNQ. is given as Y gram per DN cube, meaning that we have little information to what concerning what we have little information concerning what base. But when we look at the acid, we are given what concerning acid, we are given VA, which is 11.3 what gram, 11.30 centimeter cube, and the mass conc of A is given as 5.3 gram per dn cube. So we are given the volume of an acid, we are given the mass conc of an acid. Now, in order to get the concentration of base in mole per dn cube, in mole per dn cube, we need to use the general formula. Using the general formula of what, since we know VA, and we can easily get for CA from the mass conc of A. So we know VB, you can use the general formula called CA. But before then, you can use using what the general formula CA over CB VB equal to NA over what? NB. CA VA all over what? CB VB equal to NA over NB. Now we have what? We need CA. We have not, although we can calculate our CA from what? From the given parameter. So we need to work towards getting the each parameters of this formula so that we can use it to calculate what? CB. Don't forget that we are calculating CB in question number 1, concentration of what? Of base in mole per dn, which is known as CB. So we need to get all other factors, all other parameters in order to get what? CB. Now let's calculate CA. Now know that CA is concentration. You know that CA is concentration of A, which is our acid, in mole per dn cube. Now, which is also known as what? Molar concentration of A. Also known as molar concentration of A. And there are two types of concentration. We have molar concentration and mass concentration. And these two concentrations are, mass concentration is in what? In gram per dn cube, while molar concentration is in mole per dn cube. And these concentrations are related by a specific formula, and this formula is given as what? Molar concentration is given as mass concentration all over what? Molar mass. So molar concentration is equal to mass concentration over molar what? Mass. So which means that if I want to calculate the concentration of A in mole per dn cube, all I need to do is to just calculate the what? Molar concentration of what? Of A using the formula what? Mass concentration of A all over what? Molar mass of A, which is ACl. Don't forget that A is LCl. Now I've gotten my what? The 5.3 gram dn per dn cube is the mass concentration of A. But what about the molar mass of A? We can easily get down molar mass of A from the question given to us. Molar mass of A, which is LCl, is given as well. Look at this. What is the atomic mass? The relative atomic mass of what? Of hydrogen here is 1.0 plus the relative atomic mass of chlorine is what? 35.5, which is equal to 36.5 gram per mole. 36.5 gram per mole. Now, so here we proceed to get our, since we've gotten our molar mass of A, also which is ACl, is 36.5 gram per mole. So molar conc, which is Ca, is given as what? What is mass conc? Mass conc is what? 5.3 gram all over what? All over 5.3 gram over 36.5 what? Gram per mole. Gram per dm cube. Gram per mole. So gram cancel gram. So we have what? Mole per dm cube. Or you don't know how to carry the unit and give it. So this one times this one will give you what? 0.0, okay, 0.145 mole per dm cube. 0.145 mole per what? dm cube. So that's to what? 3 significant figure. So now 0.145 mole per dm cube. That we can now proceed to calculate our what? Our CB. Remember, I'm looking for CB. So what we just did now, we can now go back to this formula now. So therefore now CA now using CA now. So can I actually use what? CA VA now bringing out those. So we have using what? CA VA over CB VB equals NA over what? NB now. Now your CA is given as 0.145 mole per dm cube. VA is what? Is 11.3 centimeter cube. 11.30 centimeter cube. You have what? CB is what we are looking for. VA is the volume of the pipette used, which is what? VB. The volume of the pipette used, which is 25 centimeter what? Cube. Now, we're talking about NA and NB. NA is gotten from the equation of the reaction, which is 1 ratio what? 1. 1 ratio 1, we have what? NA equal to 1. NB is equal to 1. So, our NA is equal to 1. NB is equal to 1. So, using this formula now, what do we have? So, now, we have 0.145 multiplied by 11.30 all over CB VB. What's our VB? What's our CB is unknown. Our value is 25 equal to 100 over 1. So when you multiply this, you have what? CB times 25 times 1. So we have CB times 25 equal to what? 0.145 times what? 11.30 times 1. So we divide both sides by what? 25. So this one comes to CB now is equal to 0.145 times 11.30. So your CB is around what? 0.0. Let's quickly test it. CB is equal to 0.0656 mole per dm cube. So 0.145 times 11.30 all over 25 equals to CB is equal to now 0.0656. Approximately now CB is equal to 0.066 mole per dm cube. Now, the Roman got 2 questions says find the value of y. Find the value of y. Roman got 2 find the value of what? Of y. Now, we've obtained our what? Our CB, which is the first question mark 1, the constitution of what? Of basic mobile dm. We have obtained our CB, which is equal to 0.0656 mole per dm cube. Approximately what? approximately 0.066 mole per dm cube. So we need to write it out so as to. I'm going to be using it for the subsequent questions. Now, the value of x, y, the value of y. No, we are told that the acid reacts with 25 centimeter cube of a base containing y gram of sodium hydroxide per dm cube. So we have to calculate that y gram, and that is indirectly what we are doing here is y gram of sodium hydroxide per dm cube. So indirectly they are given the what? The mass what? The mass concentration of the what? So the mass concentration of what? The mass concentration of sodium hydroxide here. The mass concentration of sodium hydroxide from the question is given as what? Y gram per dm. So we are looking for the y gram. We are looking for the y gram per dm. So as this get the mass concentration, remember that from molar concentration equal to what? Mass concentration all over molar mass. When you cross multiply, you are going to have what? Mass concentration of sodium hydroxide. That's the concentration of sodium hydroxide, which is what? Which is same as what? Same as y, which is given as y per dm cube, is equal to what? Mass. Molar mass is equal to what? Molar concentration of sodium hydroxide the molar concentration of sodium hydroxide multiplied by the molar mass of sodium hydroxide. Now we've gotten our molar conc, which is what? 0.0656 mole per dm. So let's try and get our molar mass so as to use this. So that we can substitute the value into this formula. So the molar mass of what? The molar mass of sodium hydroxide, the molar mass of sodium hydroxide is equal to what? Now look at the atomic mass of sodium is what? 23. The atomic mass of sodium is 23. That of oxygen is what? 16. And that of hydrogen is what? 1.0. So everything is equal to 30 gram per mole. 30 gram per mole. That together, everything is 30 gram per mole. So therefore, we have what? Mass conc of sodium hydroxide, which is in terms of y gram per dm cube, is equal to as what? Molar conc, which is, don't use approximated value, 0.65, use the what? Original value, 0.065 multiplied by 40 gram per mole. So your answer will be around 2.624 gram mass conc per dm what? Cube. So these are y here. Since this one is 2.624 gram per 1 dm cube, that is 1 dm cube. So our y is equal to 2.624 gram. So that is that. This 2.624 gram was dissolved in 1 dm, which is 1,000 centimeter cube of what? Of water. So that's how we've gotten that one. So it means 2.62 gram of sodium was weighed and dissolved into 1,000 centimeter cube of distilled water. So that's how they prepare that. That's how they prepare sodium hydroxide. Now solution. So now let's go to the what? The mass of sodium chloride formed during titration. The mass of sodium chloride formed during titration. Here we are going to need our what? We are going to be what? We are going to be needing our what? Also our what? Our HCl plus N sodium hydroxide to give us sodium chloride plus water. That is the equation from the reaction. So from the equation of the reaction, from the equation of the reaction of titration. So we have what? HCl plus what? Sodium hydroxide to give us what? Sodium chloride, sodium chloride salt plus H2 what? Water liquid. So we have this is still what? Aqueous. This is aqueous and aqueous with sodium hydroxide. Now we have to calculate the mass of sodium chloride form. That is the mass. What will be the weight of sodium chloride form when they collect it from the end point? What will be the mass of sodium chloride? So how do you go about that? The first thing is what? Meaning that this reaction take place or titration take place, 1 mole of sodium of HCl is reacted to 1 mole to give 1 mole of what? Of sodium chloride and 1 mole of what? Water to give us. So they react in ratio 1 to what? To 1. So if that be the case, it means that the same number of moles of sodium hydroxide produce the same number of what? Mole of sodium what? Chloride salt. So now let's try and what? Look for the what? For the number of mole of sodium chloride after the what? After the titration. What will be if they react in 1 ratio? Ideally they react in 1 ratio 1. What will now be the number of moles at the end point? Or what will be the number of moles of sodium hydroxide at the end point that will produce this? Because when you find the number of moles of what? Of sodium hydroxide at the end point, it will be equivalent to what? Number of what? Moles of sodium chloride obtained at the what? At the end point. So now let's look at it now. How do we obtain the number of moles now? Number of moles of what? Of sodium hydroxide used. Number of moles of sodium hydroxide used during titration. The number of moles of sodium hydroxide used during titration will be equivalent to what? Will be equivalent to this. Will be equivalent to what? Equivalent to number of moles of sodium chloride produced at the end point. At the end point of what? Titration. So let's just, when you get obtain the number of what? When you obtain the number of moles, and you obtain the number of what? Moles of sodium hydroxide used during titration will be equivalent to the number of what? Of moles of sodium chloride produced at the what? End what? Point. Now let's get what? Sodium of what? Number of what? Moles of sodium chloride. So in order to get that, we know that what? Molar concentration. Molar concentration is equal to what? Number of moles all over what? Volume. It means what? Moles all over what? Volume. Mole over volume. Moles over volume. So molar concentration is what? Molar concentration of sodium hydroxide is equal to what? Moles all over what? Volume. Now, we are trying to get the moles. Now, in proving that the molar concentration of sodium hydroxide is what? 0. What? 0 what? Given that what? Molar concentration of what? Which is Cb all over small letter m moles all over what? Volume. And this Cb is given as what? The Cb here is obtained as 0.656 and what? Mole per dm3. Your V is 25 centimeter cube of base that was pipetted or pipetted. So this is what? This is 1000. So this the other one that we have 1, 2, 3. So we have 0.025 dl cube. So we now have our what? By simply cross multiply now the moles of what? The number of moles now. So this is now number of what? Number of moles of sodium hydroxide that was used during titration. From simply complementing it or cross multiplying this, we have what? Now your Cb is what? 0.0656 multiplied by what? V, which is 0.0025, which will give us what is 0.0164 moles. So moles. So now it's 0.0164 moles of what? Of sodium hydroxide was used up during what? During the titration. So in other words, as we say, 1 mole of this produce this, definitely 0.0164 moles of sodium hydroxide that was used up is equal to what? 0.0164 of moles of sodium hydroxide that we will obtain. So it means therefore the number of moles of sodium chloride obtained will be 0.00164 moles. So we can easily calculate the mass from what? The number of moles. Now we can easily calculate the mass from the number of moles. So how do we go about that? Let's just clean this since we're almost done. So we just use moles. You know that the moles of the substance is given by mass. So the number, so moles of the substance, which is what sodium chloride that we are considering now, we go to mass of sodium chloride all over molar mass of sodium chloride. Now, what is the molar mass? We have known the number of moles, which is 0.0164. We are looking for mass of sodium chloride, and molar mass of sodium chloride can be obtained from the what? From the question given to us. So molar mass of sodium chloride now will be equal to molar mass of sodium chloride is equal to 23 plus, because sodium is atomic mass of sodium is 23 plus what? Sodium chlorine 35.5 will be equal to what? 58.5 gram per mole. Gram per mole. So from there now, you can easily what? Get our what? Sodium what? So the moles of sodium chloride equal to the mass of sodium what? Chloride all over the molar mass. Just abbreviating it. Sodium chloride. So the mass of sodium chloride is equal to what now? I simply cross multiply also. And cross multiply this one times 1, we have what? The mass of sodium chloride is equal to what? Number of moles of what? Number of moles of sodium or chloride times this, which is NaCl multiplied by molar mass that we just obtained. So to avoid prolonging things unnecessarily, just substitute the values. So we have what? Number of moles is 0.0164 multiplied by the molar mass 58.5 gram per mole. So we know that what? The mass will be in grams. So this will be give 0.009 0.0956 gram. So approximately what? 0.096 gram of sodium chloride that will be obtained at the end of the titration. Please read this very well. If you have any question, please make sure you ask in the comment. In the comment box, make sure you drop your comment in your question in the comment box. Now, so the next thing is what? State the indicator that can be used. State the indicator Let's quickly move this one. Now the question B now, the B aspect of the question, yeah, very much go on. State the indicator that can be best used for the titration. Now, if you want to know the indicator that is best, that will be best for the titration, you need to know what type of acid is what is being, what type of acid is used, or what type of what base. What is the alkalinity of the base, and what is the acidity of the base that were being titrated together. So what do you mean by that? We need to consider the equation of the reaction, which is what? HCl plus what? Sodium hydroxide plus, to give you sodium chloride plus water. Now, here now, the acidity of what? Of HCl is very, very strong. So HCl is a strong acid. So it's a strong acid. It's a strong acid against what? And the alkalinity of what? Of sodium hydroxide is also very, 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 very high. It's very basic. It's around what? 13, 14. So the strong what? Base. Now it's a reaction between strong acid and strong base. So when you're having what? It's a reaction between strong acid and a strong base. Any indicator is suitable. Any indicator is suitable. And we have many indicators like that. Indicators suitable, e.g. we have methyl orange. We have methyl red. So that indicator that we have. And we have also have what? We have also have phenolphthalein. So any indicator is stable, so you can use methyl orange, you can use methyl red, you can use phenolphthalein, depending on your choice, because we are dealing with strong acid and strong base. Now let's go to Roman 2 of the B. It says take the column of the indicator mentioned in Roman B1 at the end point. Now, end point, what will be the color of the what? Of your titration at the what? End point. Using each of what? Now it depends on the indicator you are using. If I'm using methyl orange, I'm going to have orange. If I'm using methyl red, I'm going to have red. If I'm using phenolphthalein at the end point, I'm going to have colors. So you are going to draw them, draw a table. So we have what? So if I'm using indicator number 1, I'm using indicator number 1, which is what? Indicator. We have what? Color at the end point. Note at the end point. At the end point, because this color at the end point, because this indicator has the what? The type of color they have in what? In acid and in base. So they are talking about when after you have what? You have added your what? Your acid into your base. That's what at the end of the reaction, want to be the color of the end point. So that's what they have to color at the end of the reaction. So number 1, the methyl orange. Methyl orange. We give what? Orange color. Orange color at the end point. So we have the methyl red. The methyl red will give you what? Methyl red will give you what? Red color, and phenolphthalein. Color what? Colorless. It's as if the color of the end point is what? It's the same thing as the color of the indicator given to you. But just know that in real practical, you understand what I'm saying. But we know that the methyl orange, the color at the end point is orange. The color at the methyl methyl red. You see, you can see red. You have what? We have red color, and the phenolphthalein is colorless. It's colorless. So we have colorless at what? At the head point. Please, if I have any questions, remember to drop your comments or your question at the comment box below. Thanks for watching our YouTube. Please stay online for what? For another subsequent video on on volumetric analysis and how it is going to be set in in GCY. It's very, very important you understand the concept and the methodology they use to set questions, so I will not study amiss. Thank you. God bless you. See you next time.